Hello, welcome to my presentation. My name is Lisa. I'm from ABB Research Center in Raleigh, North Carolina. This research work is driven by the integration of distributed energy resources, focusing on solar PV integration. Because of interconnection codes, DRs have to stay online at faults, therefore change the fault distribution and causes protection issues. Many types of DERs are DC sources like solar PV, like battery energy storage. DC integration has better efficiency and reliability, which makes hybrid AC/DC a promising trend in future distribution network. Protection of the AC distribution with solar PV integration has been studied by many researchers. Therefore, this research work focuses on the protection issues and potential solutions in DC distribution and between AC and DC subsections. In US, utilities normally adopt fuel saving for conventional distribution network. Fuel saving can still be used by DC distribution like this figure shows. Because of the reduced or increased fault current flowing through protection devices, mistripping or sympathetic tripping can occur in DC distribution because of the solar PV integration, like these two figures illustrate. Another issue to be noted here is when there is adaptive protection, the DCC protection curve is shifted upwards because of the protection coordination requirements. This can make the mistripping happens at even lower penetration level. This slide shows the protection coordination issues between AC and DC subsections in a hybrid distribution network. There could be two kinds of configurations. One is AC and DC, they are on different feeders. The second one is AC and DC, they are on the same feeder. For the first one, sympathetic tripping still occurs because of the higher than the designed fault current values of the neighboring feeder. For the AC and DC on the same feeder, because the DC circuit breaker normally has much faster protection speed than AC, then even without solar PV penetration, mistripping or the field operation of the AC circuit breaker still occurs. To summarize, these are the reasons causing protection issues in field saving protection of hybrid AC and DC distribution. The first one is bidirectional fault currents caused by solar PV integration. The second one is different fault current direction and magnitude flowing through protection devices than the original designed values. The third one is normally DC circuit breakers has much faster protection speed than AC circuit breaker, which causes protection issues, coordination issues between AC and DC. The last one is if there are intersections of time current curves or adaptive protection is adopted, then the protection issues like mistripping, like sympathetic tripping, could be worsened by these two things. What are the potential solutions? First, try to make sure there are no intersections or intersections are unavoidable. Try to push them as much high as possible. The second one is to use coordinated control and protection design for inverters and converters. The third one is use AC or DC fault current limiters to reduce the impacts of the fault contribution from the solar PV integration. The last one is if it is unavoidable, the fuse blowing, then just use the fuse blowing at high current levels instead of fuse saving. Okay, this is the all of my presentation. Thanks for your attention. If you have any questions or comments, please do not hesitate to contact me. Thanks.